This video focuses on the basics of hypothesis testing, specifically null and research hypotheses. For any field of study, there is specific terminology with its own precise meaning. And as with any field, understanding the meaning of a few key statistical terms will help reduce confusion many experience when thinking about statistics. Statistics is a branch of mathematics based on probability. It can be thought of as a tool to help researchers make decisions in the face of uncertainty by basing these decisions on probability. Researchers generally study phenomena by gathering data from samples drawn from a population of interest, and then generalizing from those samples back to the population. Researchers do not study the entire population because it's usually not feasible, due to time, cost, or just practical limitations. If you are studying patients with periodontal disease, the population is all patients with periodontal disease. But you cannot collect data from everyone in the world with periodontal disease. And even if you could, you would still miss those whose periodontal disease is yet to be diagnosed. And those who might develop periodontal disease in the future would also not be included. So instead of trying to collect data from an entire population, the researcher chooses a sample that represents as closely as possible the population of interest, and then makes generalizations or inferences to the entire population based on these sample results. A scientific hypothesis is a precise, testable proposition about an area of study. It is a critical component of the scientific method, the systematic search for knowledge through observation. For example, suppose that a dental researcher believes that a toothpaste with higher fluoride concentration will result in better remineralization of root caries than one with a lower fluoride concentration. How does she examine this question scientifically? She would have done preliminary research in this area before getting to the point of doing a study, including reading the literature and possibly doing a bench test or pilot study. A true experimental design includes a control group against which to compare results of the intervention. The researcher decides to examine two groups: patients who receive a higher concentration of fluoride and those who receive the standard concentration. Colgate Winterfresh Gel is a toothpaste with 1100 parts per million fluoride. It is sold over the counter and will serve as the control. Colgate also makes Prevident, a prescription toothpaste with 5,000 parts per million fluoride. This will serve as the experimental condition. The researcher starts with a research hypothesis. She is studying two different fluoride concentrations, and she would have to operationalize what she means by better remineralization. Let's say that she measures it using electrical resistance values based on electrical caries monitor or ECM scores, with higher ECM scores indicating better remineralization. She expects a higher mean ECM for patients using Prevident than for those using Winterfresh Gel. To test her hypothesis, she sets up another statement called the null hypothesis, a statement of no difference or no effect. For this study, Prevident does not provide better remineralization than Winterfresh Gel, or there is no difference in mean ECM between the two products. The null and research hypotheses are mutually exclusive and together account for all possible outcomes of the study. In this case, Prevident either does or does not result in better remineralization. Rejecting the null hypothesis means support for the research hypothesis. Conversely, accepting or failing to reject the null hypothesis means lack of support for the research hypothesis. Researchers are usually not happy with this outcome, as they are generally looking for support for the research hypothesis. Here's how hypothesis testing works. The researcher focuses on the null hypothesis. She does this by creating a distribution of all the possible results that can occur when the null hypothesis is true. As long as certain assumptions have been met, this is what such a distribution would look like. This shows all the possible values for the difference in mean ECM, Prevident minus Winterfresh gel, which I've abbreviated WFG, when there's no real difference in remineralization between the two products. Notice that 0 is at the middle of this distribution, but there's also a range of values to either side of this 0 point. If the null hypothesis is true, the researcher would expect her sample results to be around 0. But because of sampling variability, she might get results that favor Winterfresh gel or results that favor Prevident, even when there is no real difference between the two. This is the model that represents the null hypothesis, and the researcher hopes to reject it, thereby supporting her research hypothesis. The further away her results are from 0, in the positive direction, the more likely she is to reject the null hypothesis. She's only looking in the upper half of the distribution because her research hypothesis is that Prevident results in better remineralization. To summarize, the first two steps in hypothesis testing are to first state the research and null hypotheses, and then draw a model of the null hypothesis, that is, a representation of all the possible results when the null hypothesis is true. The next video in this series focuses on how the researcher decides to reject the null hypothesis.